Morning, lesson 9. Now this is coming off of yesterday's lessons with the equivalent fractions. So anytime that the denominator is the same, it's easy to compare because you're just looking for who has more pieces, because all the pieces would be the same size. They'd all be eighths. So what's more, 7 or 5? That one's not too bad. Now, second one is a little bit trickier because you're comparing fourths to eighths. And it's harder when you don't have the same denominator, but what you could do is just look at the numerator and say, okay, if you have a pizza that's divided into fourths, and if you have a pizza that's divided into eighths, same size pizza, what's going to be more? Well, 3/4 is a lot, more than half. 3/8, not even a half. So if you have 3 slices but they're way bigger, so the smaller denominator, the bigger the slice, you can easily compare. Now other people really wanted to stand out, so this is where you could use your equivalent fraction work. So right now the denominators are not the same, but if you were to make an equivalent fraction of 3/4 into eighths, you could take each of those 4 pieces and cut them in half, meaning double them. So we're going to multiply times 2. Take the numerator and double it. So 3/4 is equal to 6/8. So now when you're comparing, 6/8 is this, we're speaking eighths in both. So 6/8 is really twice as big as 3/8. So you can either, like these match the numerators. This one's a little bit tricky because you have 3/4 and you have 6/8. So that's the one that we just did over here. So if you were to make 3/4 into 6/8, you would see that they're equivalent. Now you could go back to that one of the previous pages where they actually have the fraction pieces too, and you would see that. Because if you were to double the denominator, that would be eighths, and double the numerator, that would be 6/8 is equal to 6/8. And this one you could make halves into sixths. So 1/2. And then if you were to make those into sixths, you'd have to go 3 times bigger, 2, 4, 6. So you'd have to make the top 3 times bigger. So 3/6 is equal to 1/2. And then you compare 3/6 and 5/6. So a lot of good thinking, good problems. Not easy. Now this sheet is a little bit different because now we're not talking about the same. I mean, we've always talked about like the same size pizzas, the same size everything. Now we're looking at just buttons and balls and money and coins and fruit, and so it's a little bit different, but we're grouping them. So we have whole buttons. So what fraction of the buttons are large? Well, if you look at it, there's 1, 2, 3, 4, 5, 6. There's 7 total buttons, so that would be our denominator. How many of them are the bigger? It looks like just 2. So the whole group, 7 buttons. 2 of them bigger. What fraction are soccer? So if I count all of them, that's 4, 8, I get 11. And it looks like just 4 of those 11 are soccer balls, which would mean 7 of the 11 would be basketballs. So 11, so it'd be all of them. All right, so you just need 4 11s. So this shouldn't be too bad. Now down on the bottom, shade the given fraction for each set. So 4, 8, there's 11, so you'd have to shade in 7 of them. There's 9, so you'd have to shade in 2 of them. So we're just talking parts of a group. So we're starting to look at wholes, like that's a whole basketball and that's a whole soccer ball. But they're all in a group, so we can count them as a whole group. So of the 11, 4 of them. All right, have fun.